Dear learners, wishing you all the blessings and happiness in your life. What is the basic difference between uniform speed and uniform velocity? Or you can say, if there is uniform speed, then is it necessary that the velocity will be uniform? We can explain it by an example, practical example. Here, a boy is rotating a stone which is tied up with a string, and he is rotating it over his head. Now it is an example of circular motion. So it is clear that the speed is uniform because there is no change of magnitude. Magnitude is same, average magnitude is same, but the direction is changing continuously. Here the direction is changing continuously. So here the direction is different. So we can say that we know that velocity is a vector quantity and speed is a scalar quantity. So as the direction is changing, so velocity will be changed. So there is no uniform velocity in spite of having uniform speed. So we can say that if an object is moving in a uniform speed, then it's not necessary that the velocity will be uniform. But if the motion is linear or the direction is same, then the speed and velocity both are uniform. I hope I can make you clear. Dear students, what is the basic difference between distance and displacement? Distance is a very common word we use in our daily life, but displacement, it is quite uncommon, and we can explain it by a practical example. Here, suppose a boy is driving in a hilly area and the car is moving along this road, and the car reaches the point at B from A. So here the distance is 4 km from along this hilly road. What about displacement? Displacement is the straight line from point A to B, and the direction is from A to B, that is 3 km. So distance is 4 km and displacement is 3 km. I hope I can make you understand. Now there is a common question that if the distance is increases, then is it necessary that displacement also increases? So let us explain it first. At first we observe that the car is moving along this hilly area on this road from point A to B, and then again the car is moving from point B to C along this road, that is 5 km. So the total distance the car covers is 5 plus 4, that is 9 km. So here the total distance from point A to B to C is 9 km, but the displacement is from point A to C, that is straight line from point A to C, and the direction is from point A to C. Here the direction is from point A to B, that is AB, and arrow sign overhead. So here the distance is from point A to C, that is A. So we can say that here the distance is from point A to B to C, that is 9 km, and displacement is only 2 km. Here the basic difference is this. Now what is speed? Speed is very common word in our daily life. It is the rate of change of, it is the distance covered per unit of time. That is, if we, for example, if a car is moving 50 meter in 10 seconds, then the speed is 50 by 10, that is 5 meter per second. Here direction is not so important because it's a scalar quantity. What about velocity? Velocity is obviously vector quantity, so in that case direction is necessary. And displacement, velocity is displacement covered per unit of time. That is, velocity is final position minus initial position by time. Again I am saying velocity is final position minus initial position by time. And here direction is important, that in which direction it is moving. Either it can be in the east, in the west, in the north, in the south, any direction. But direction have to be mentioned. Okay, direction have to be mentioned here. So, what is instantaneous speed? The speed which is at a very small time very near to zero but not exactly zero. Here we can express this instantaneous speed, that is small b. Here limit is del t very near to 0 but not 0, del s by del t. Here del s indicates that the difference is very small, del s by del t, that is ds by dt. So instantaneous speed is a speed at a very small time very near to 0 but not 0. Okay, I hope I can make you understand.